Hi grade 9s. Today we are going to learn about elements and compounds, and so this will be lesson 1.9 for you. Okay, we're going to review first the particle theory of matter. So matter is made up of very tiny particles, okay? So you would have seen this probably around your grade 7 science class. Maybe you talked about the different states of matter. I think technically it's also in like grade 2 or something like that as well, or maybe a little older. Anyways, so you would have looked at the different states of matter, and so we know that matter is made up of very tiny particles, and you can write this down here. So our solid, the particles are very close together, liquid a little farther apart, and then in a gas they're quite far apart. Now, all matter can be divided into two subgroups here. So we have heterogeneous and homogeneous. So heterogeneous, you can see have different parts. You can write that in. So oh, I forgot. Oh, I spelled that completely wrong. Hold on. There we go. Okay, so you can see different parts in something that's heterogeneous, whereas in homogeneous solutions, they are the same throughout, okay? So you can't see different parts. Now, within the heterogeneous side here, we've got something called mechanical mixtures, and this is just sediment rock, the different layers of rock that you can see, and you probably would have learned about that in your grade 7 science classes too. So mechanical mixtures, but we're not going to worry about that too much. In homogeneous mixtures or homogeneous solutions, we can have solutions here. So this is our Kool-Aid. Some of you will have drank Kool-Aid at some point, or iced tea or anything like that. Whenever you dissolve something in something else, you end up having a solution like this. So a solution is the same throughout, so you can't see the different parts in it. A pure substance is also homogeneous, and it includes, this would be NaCl, so compounds, molecules, and the elements for the pure substances. And we'll talk more about these in a minute here. Okay, so a molecule. You can write this down. A molecule is composed of a cluster of atoms and can be broken down into these atoms during a chemical change. So here I've shown you this is one N and 3 hydrogens. This would be NH3. Other examples of a molecule are things like Cl2, if I have, that's a little 2 there. If I have 2 chlorine atoms that are bonded together, that's called a molecule. Now an element, we know what elements are, we've been looking at them for a while now. An element is a pure substance whose molecules are made up of identical atoms. So for example, this of course is gold here. So if we look at a bar of gold, that is pure gold, there's nothing else in there. So if you looked at that under a microscope, you would see all the different atoms of gold there, okay? And so all of the elements are considered pure substances. And lastly, we're going to look at compounds. So a compound is also a pure substance whose molecules are made up of different kinds of atoms. So molecules and compounds are sometimes that you can use them interchangeably, kind of, or I should say all compounds can have molecules, but not all molecules are compounds. Yeah, that's better. Because remember we talked about Cl2 being a molecule. Cl2 is a molecule, but it's not a compound because compounds have more than one thing, okay? So a compound, for example, water, we've got H2O made up of hydrogen and oxygen, and here's methane gas. This is our natural gas, which is 1 carbon and 4, we've got our 4 hydrogen atoms there. Okay, so those are compounds. Now, we're just going to go through and classify these things as to whether they're elements or compounds. So I've got, these are all pure substances. So first here we've got silver. So silver, is it an element or a compound? Hopefully you came up with that being an element. Good. Next one, sodium chloride, element or compound? Compound, because it's got more than one type of atom in it. Now sugar. Sugar, now I could give you the formula. So the formula is C6H12O6, but you don't even need it because you know that it's not an element, okay? So basically anything that's not an element, and if I tell you it's a pure substance, it's going to be a compound. Baking soda, same thing, that's sodium bicarbonate, it's going to be a compound. Water, compound, and our carbon dioxide here, also compound. So the elements are literally just what you find on the periodic table. Everything else there is going to be a compound. Okay, so chemical formulas. The combination of chemical symbols that indicates what elements and how many of them make up the compound. So we're used to seeing these in our life, like these ones people tend to know right away. Salt actually is one that people often know as well. So we're just going to go through here and indicate what makes up each of these. So first of all, we have H2O. So what do we have? We've got 2 hydrogens and 1 oxygen. Okay, so that's how let's actually write the whole things out. This is an oxygen. Good. Now O2, remember, is not a compound, but this would be called a molecule. How many, or what do we have in there? Yeah, so this would be 2 oxygen atoms bonded together. And then we've got sugar here, and we've got 6 carbon, 12 hydrogen, and then 6 oxygen. So those little numbers after, that tells you how many atoms there are. And if there's nothing there, like in the oxygen, you know, there's nothing there, it's blank, you assume 1, okay? So it's 1 unless there's another number there. Okay, so that's that. You can just go through there and yeah, that's it. Let me just do another one here. So if we had NH3, how many nitrogens do we have? 1. 1 nitrogen. How many hydrogens? 3 hydrogens. Good. So fairly straightforward. Now your assignment is, you've got a sheet for the chemical symbols and formulas worksheet. So you can finish that and we'll take a look at that tomorrow in class. Thanks everyone.